Hello everyone, I'm Japnid, and I'll be walking you through our next unit, Unit 2, of Advanced Java, which is Conditional Logic, Loops, and Arrays. So in this section, we will first explore conditional logic, because it's sort of essential for understanding how loops work and why they're useful in the whole context of Java. So as a preface, we humans regularly rely on logic to function correctly, like trade, survival, social situations, etc., etc. The Java API extends this human feature on a computer. So instead of using just like binary 0, 1, we'll just say, okay, if, yes or no. And it uses the keyword if, which I will highlight here. So it sort of does as one expect. If you have a set of parameters and they're true, you have to execute something following it. So in this example here, I have the Boolean check if declared, and if check if happens to be initialized to be true, do something, which is a method I haven't declared yet. It will just do something, right? That's just the basic way how it works. And the syntax is if parentheses argument and code block following it. But this is more of a trivial case. So if this was true, then this would execute. But needless to say, if it wasn't true, it wouldn't execute, right? So in real life scenarios, you'll be dealing with a range of numbers or objects. So you would need to use something like inequality signs or equality statements. So here's an example I wrote here. So let's say I wanted to check if a number is odd. So what's the property of odd numbers? When you divide them, there's always a remainder of 1, right? So let me just execute this code quickly. And I want to check if the number 3 is odd, and yes, 3 is odd. So what is going on here is that this is a scanner, and the scanner, which you will maybe learn later, is something that just takes your input, right? And you'll learn about it more on, but what I'm doing is I'm taking this input, making it into an integer, and then I put this into an if statement. So there's two important things going on here. First is this modulus statement. So this modulus statement, if you maybe remember for a beginner's Java, it just gives you the remainder of something. So if I divide 5 by 2, the remainder is always going to be 1, right? And any odd number after that. So which is why I put 1 on this side. So because the property of odd numbers. The next thing is this double equality sign. So why does Java have a double equality sign? Why did I put this here? Why not just 1? Java uses the double equality sign as a check. It doesn't. It's not like declaring a variable where you just set it equal to something. This is called a equality check. So it just checks if this remains true, if this variable is in fact odd. And once that happens, it will just say the number is odd. Right? But this is only the case with primitive variables. So in real life, with objects, you would need to use something like .equals for string or .compare, stuff like that. Object exclusive methods in Java. So here's another example you might encounter in like higher levels of Java. So let's say I wanted to, let's say a real life situation, I wanted to modulate my temperature so that like a system doesn't overheat. So ideally, this means cooling to the point where water doesn't boil, which is 100 degrees Celsius. So this program that I'll write will notify you whether it's overheating. So like imagine like a sci-fi pilot and he's been hit and the computer like says the system is overheating. They can use this like really simple code that I'm putting here as a way of just checking if it's overheating, right? So let's just extend the concept of the if statement, right? So let me just check this quickly. So let's say this is 97, right, which is below it. It'll just say it's going to overheat. It won't do anything. But if I put something like 100, but if I re-execute it and then I do something like 101, then it's going to overheat. Right? So moving on. Now let's say I wanted to deal with more ranges. So let's extend the concept with the else statement. So what the else statement is that if your conditions, if this whatever you input is outside these conditions, what happens, right? As a programmer, you want to deal with every single case that's given to you. So no matter what number your user puts in, the computer will respond accordingly. So let's take another example. Let's say I wanted to like in a typical sci-fi fashion, I wanted to let them know that the system is optimal, right? But in order to be optimal, it also cannot freeze, right? So I'll just put else, which is just if the first if statement doesn't work, you will automatically move down here. So let's say temp is less than or equal to 0, which is the freezing point of water. And I would say system dot out, sorry, and I would say freezing, right? And then I would also have to let them know that everything's fine, right? So else, because if it wasn't in the range, then it would just be fine. It can only be in if it's outside this 100 to 0 range. So system dot out. Okay, so let's just execute this again, and let's say I wanted to have -2. Now it's freezing. Negative 2 degrees Celsius is definitely freezing point. Let's say it's 56. Yeah, it's optimal. So now you're dealing with ranges by using the else statement. Now keep in mind that the else statement cannot exist without the initial if statement. You can't use else independently of if. Alright? Okay, so let's get a little bit more advanced. So what if you want to deal with like a certain range of data, right? So let's say you're a grader and you want to grade students on their academic performance, numerically of course, right? With A's, B's, and so on and so forth. And then within that range you want to have pluses, neutral, and then minus. So this range has a little bit more complexity to it than we originally imagined. So what we would address it with is a nested if statement. So you have an if statement within an if statement, right? So it will satisfy the outer condition, and then it will move on to the inner conditions, right? So we have 1 here, and then 3 within that block of code. So first it will check whether it's between 90 and 100, which is a typical range for the A grade, and then we'll check from 97 to 100, that will be a plus, 93.5 to 97, that's neutral, and then 90 to 93.5. So now you're dealing with more specific ranges. So what would happen, and if it's not in, then I would just say it's not in the valid range, which I want the user to put the data, right? And so let's just test this. Okay, so let's say the student got a 95%, right? So he would have a neutral because it's within this range. Now, something I want to address, within this declaration I've made it so that it outputs a string, right? So so then some people would ask, okay, then why would you need this one if everything is going to return a statement, right? The problem is that now this is unreachable. What unreachable means is that, okay, what if nothing satisfies this range, even though I put an else statement here? This else statement is conditional. It depends on if. So what if I put nothing, right? What would it output? Java has this sort of behavior that you need to have an output, a guaranteed output. So you would just put return str just to ensure that if nothing satisfies this range. Alright? So now you are in possession of one of the most powerful techniques in Java, which is conditional statements.